Hey everyone, so POPs are out in TouchDesigner. POPs stand for point operators and they let us do a lot of the cool stuff that we could do with SOPs and CHOPs and to an extent some TOPs. But today I'm going to just give you a first look because I've been playing it with these for a little while and show you some of the ins and outs and some of the things that I have really enjoyed playing with. And this is going to be far from an exhaustive list because I am also getting the grips with these newer operators. But they're really cool and exciting, and I think there's a lot here. So let's dig in. At the most basic level, we now have this new menu bar for point operators. And we can see looking in here that we have lots of options. And like the other TouchDesigner families, we have essentially things that generate information and things that process information. So in terms of generating stuff, we have lots of things that might be familiar to us. We have things like the point generator, which is a bit similar to stuff that was in the palette earlier, although it's got its own tricks. We've got sphere, we have box, we have a grid. So a lot of this stuff is going to look kind of familiar to us. Let's see, let's just do one more thing just so we can see. In terms of how we process these generators, we have a bunch of things that we also might be used to, like we have noise and twist, but also some things that we are potentially less used to, like one of my favorite things that I think is going to solve a lot of problems for people, which is this little thing called proximity. And what proximity allows us to do is essentially create these sort of plexus effects, and maybe this would be more interesting if I popped a noise in here. I'm going to turn up that value and I'm going to animate it. So now we have a really simple inbuilt way of making a plexus model. And what's actually happening here is kind of the power of POPs, and this is what I'm going to show you and expand upon. So what we can see here, and let's bring that out into a bigger view, is we have all this data and all the attributes from these objects. And so we have our index, we've got our point values, our normals, but then we've also got the attributes of this noise that are coming in too. So essentially we have this chain of all this data that we can work with. And this becomes really powerful with some newer objects, which I'm going to show you, called the math object, and they kind of really develop on the math objects that we have before. I'm going to close this up and show you a few other projects and just things that I have sort of been working on to just get an idea of what the potential of POPs are and what these things can do. So something we've often done before is we have made these sort of particle systems, and these particle systems we have some kind of life component which essentially resets. And so previously what's happened is some kind of pixel math version of this, where when a pixel gets to a certain intensity we reset. So we have our position vector, but also we have essentially like a 0 to 1 life multiplier, and that controls whether we see the active particle or reset it to its original position. So when we come to POPs, we can actually chain together a bunch of attributes. So before I kind of go through this network, let's see what's going on at the end in terms of just that data chain. Let's make it big. So we can see here again, we've got our point positions, and then we've got all these positions and attributes that have been set out by me. So for example, we can see here everything's moving, but our initialized positions, which are stored as attributes, are not. They're static in this feed of data. And that means that when I need to reset, it's going to move back. We can see here I have this do reset and reset parameter, and we can see that it's cycling from 0 to 1. So when this do reset hits 1, it's going to reset that particle, and then I need a secondary way of kind of resetting that back. This is maybe a little bit convoluted, but this is kind of my first pass at doing this in POPs, and this is going to get more streamlined as I go. We have this life max parameter, which is kind of being fed by this random, where I take every value of my points and I'm essentially creating a random value for each, and we can use these sliders to offset how random that is. So if I go all the way down and restart that, we can see that this is basically resetting really, really quickly. But I could go up and have a potential reset of like 4, which means that the particle potentially could get to a further distance before resetting. So basically what I'm doing here is I'm putting together the attributes that I actually need. So I know here that I want to use random. So I'm labeling the random value life max. So I'm taking that value, which I've created here. I've labeled that in the attribute scope. And this is something that as we actually go through proper tutorials of how to build stuff, we're going to get more comfortable with. But basically we have to label a lot of these parameters. And so I'm putting that into this attribute combine, which is basically adding that attribute to my long list of attributes that's growing. We start off a feedback, which basically is very, very similar to what we've worked with before, where everything is basically running. It's taking that data and then feeding that back, and it's incrementing step by step. So what's happening in this feedback loop is I'm starting off with something called a math mix, and I'm incrementing here in this uniform. This is basically the increment for how fast I move from 0 to whatever my limit is. This is the step size. Let's kind of bring that down again. And then the combine tab is where we see these parameters that we're setting out. So in this one, it's pretty simple. I'm basically taking my life, which is being defined in this earlier parameter, and I'm feeding it into life inc. So basically, this is my life parameter being incremented by life inc. So life inc is incrementing by this step. Feeding into noise, just displacing that as we are kind of used to with our noise displacements, and that's just offering this kind of displacement vector every frame. And then I have a life mix here. And so I've got some uniforms, which is basically like what is my maximum life and what is my 0 value. And then something a little bit more complicated here. So I'm doing a check to see if the actual lived life is exceeding the maximum life. And I'm resulting this scope with a parameter I'm calling do reset, which is going to just make a reset. So that's that 0 to 1. And this is a Boolean operation, so it's going to be 0 or 1, true or false. So then what I'm doing is I'm minusing my 0 value from this do reset. So this is essentially creating a sort of an inverse. So whatever my value here is, it's going to alternate between 0 and 1. And that's going to determine if I am staying or resetting. And if it is a stay value, which essentially means my particle's alive, I'm going to times that value by b, which means my particle is going to continue moving as it would before. So basically it's not being reset. My particle is being fully impacted by that displacement of noise in the feedback loop. And I have a little parameter scope here that means PMA. So I guess this was standing for premix A. And then after that, I'm also creating a reset for my premix B. Essentially, we have to mix between these two states. So I'm multiplying and setting that up. We start off a feedback loop, which is extremely similar to what we're used to, where we basically have this process chain that processes and then feeds back and does that multiple times per frame, creating these offsets using this chain that involves this noise displacement. And I have a couple things here, and what we can see I'm doing is I'm setting uniforms here. So for example, this life increment allows me to speed up or slow down how fast my object gets to its end result. So basically its life value. So this is basically like how fast are we stepping through the perceived life of that particle. So we can slow that down or speed it up. And so uniforms are basically things like a constant, where you would set this like you would in a GLSL uniform. And you just put that in, it's going to stay static. In this case, I just have a float, but you have all these options here for things that are going to be multiple streams of data, so vectors. And then this is kind of a simpler mathematical operation than what you'll see in a minute, but basically I'm just creating a addition every frame. So A plus B, and so this is life plus life inc. So whatever the starting life value is, it's going to add to that by this increment every frame until we hit our maximum life. And then in this life reset, we are going to reset that. So we have a few, sorry, in this life mix, we're going to skip ahead. We have our noise here, which is basically what's driving that movement. And our life mix is really what helps us set between the maximum life, where we then reset. So basically it's our kind of trigger to tell when a particle is allowed to be moving and when it sort of resets at its original position. I have a couple of things here. So I've got my maximum life value. This is the number we're stepping towards. And I have this 0 value, which actually should be called 1 value, because this is basically a static value I'm using to invert. If I'd known a little bit better about how to do this stuff when I made this network, I would have created an attribute earlier down the chain, which would have fed in, and I wouldn't have had to make this uniform. But that's kind of something that, you know, as you learn this framework, you get better at. But basically in this combination, in this combine tab, I've got a bunch of logic here that's basically like, when the life value exceeds life max, I do a bunch of steps to reset that particle. And so basically what that means is I'm checking to see if I'm staying or not staying, and then I eventually do a reset, which moves that particle back to its original position. I had to do a little bit more at the end just to make sure I'm resetting also the reset. So before I added this section, and I can just take this out so you can see what happens. Once everything resets, the particle's essentially being deemed as dead and reset, but that value is not re-triggering. So this is just a little extra bit, and you can see there's a uniform and there's a little bit of logic here, which just means I can reset that particle. And maybe I did this in a slightly convoluted way. You could also just keep adding to these things. So I could actually just add and have all my logic in one math mix pop. But for me, looking at that at this point, as I'm still getting used to this, is a little bit confusing. Even this kind of chain of thinking I found a little bit confusing, and took me a while. And I actually used a little bit of sort of writing things out on paper to think through this logic step by step. But this is something that is, you know, it's a really useful way, because think about how streamlined this is in comparison to some other things that we've worked on. Other things that we can do, and let's kind of do this in what makes sense to show. Other things we can do is we can move from tops to pops. So in this case, I have this kind of little network here that's going on in tops, and basically I have some noise, and I'm just manipulating that noise with a blur. And then I'm also taking a UV. And so I'm feeding these things together in a math mix. We can see there's no uniforms there. I'm just taking the normalization of A from position, so from this top here, from this null, and I'm giving that a result scope of L, and then I'm using this little A minus B, so I'm taking my parameter from in1 for position, which is this thing, and I'm minusing L. So let's see if I just minused P, we get a different output. Or let's see if I go back to L and say A times. And let's turn this to a panel and actually view this in the panel, so I can actually move it around. But basically we can do a bunch of just fun math experimentation here, just kind of seeing what happens. And essentially that's what happened here, is I was just playing around with some of the things that I kind of vaguely knew and just trying to see what would happen. And I think the result is kind of neat. And you can also get just cool static patterns by manipulating these as well. So this is something that is worth playing with. And what we can see is, again, very few operators are used to make this thing that's actually reasonably complex looking. Something I find also very cool about these operators is that we can actually just bang this into a geo and render it. We don't have to instance. We obviously could instance because we have all of that point information, but in this case I can just move through and have it be kind of output, and it's going to directly output all those points, and I can just add on whatever I want. And because we have these point normals, we can easily work with a point sprite and have that attenuate via this control. So that's super cool. Something else that I think is really useful is we have this ability to essentially delete data. And this is kind of like if you work in 3D where you can delete subdivisions and all that kind of stuff. But in this case, let's say I wanted to have a more sparse version of this. I could thin this out and instance some kind of different geometry. So let's give that a go. So for that, I would go to the Thin tab, and we can do this thin step. And we can see that that's starting to really thin it out. Or we could also do thin random, which basically is a threshold between 0 and 1. And I guess in this version, if we get to 1, it shows us everything. But as we move that down close to 0.9, we can see a much sparser version of this. So let me kind of go ahead and just instance something. Let's see if I just pop that in to a geo. And these will directly input into a geo. Actually, what I want to do is I want to go in, I'll delete that, and I'm going to make a box. And I'm going to take that uniform scale, move it way down. We can see it's a really big box. Okay, my video stopped recording there, but basically I have started taking down that uniform scale. Just put it like 0.05, so it's pretty small. And then we can instance just like we normally would, and this is basically, the same process for this geo. So I'm going to bring in my delete. I'll do it as the default instance, and I found this to be quite useful because previously I would work with maybe multiple tops to instance various parameters, but because we can basically store everything in one large kind of pop, we don't really need to do that so much because I can just pack those attributes together. So let's say I want to translate my P0, my P1, and my P2. And we can see we've got these little things that are appearing. And now let's say, let's just give it a, I don't think I have a light in here, so let's just put a constant on it, onto that geo, and let's color these like pink. And then obviously you have all this data that you could maybe do something with. Like right now we have just like, like length data, which isn't super exciting. But I could go in, and this is maybe a showcase of how we might actually pack some kind of attribute together. Like let's say I did a math operation on this. And then I said attribute combine, and I'll actually start off with that, going in there, and I'll plug this in. So before I tweak this math, let's set up that attribute. And so we can see when I add in the second link, this inpops grays out, which means we have a second operator that it sees. And so I can select P or L, and I'm going to select L, and I'm going to rename it to rotate. So now when I go to this section here, I've got my rotate 1, 2, and 3. And let's just say, actually, let's just do that. In my math, let's try scaling that up to like 100. Aha. And also this is important, right? Like we see that not much is happening as I move this around. And this is because I'm looking at the P element. So let's actually look at that L element. So now let's see if this actually works. There we go. So then I have rotation that is linked to that L value. And I could obviously go in and I could do more stuff. I could go and say, okay, I want to get the degree of that. So as things go round, we can see that we have these sort of boxes being more manipulated by the movement and splayed out, which is actually kind of a cool effect. So this is something that you can do sort of relatively easily. And I guess as we're here, I'm going to show you basically my favorite addition to this new POPs. Everyone wants to do plexus, including me. And now we have a very funky object called proximity that allows us to do that. And it works really efficiently with a lot of particles. If I hook that up to another geo, and let's just set up a constant there as well and color it in like something garish. Let's go for yellow. Gross. And that theoretically should be rendering out. I'm just going to make the proximity way more intense. There we go. Maybe if I used a line render, it would be more obvious, or if I turned off this geo. So what we can see is we have this method of connecting things, and we can turn up or down how connected things are. So now things start to connect when they kind of get pushed apart, and there's some of these blocks. But we can also set up a minimum distance, so basically like it won't connect unless it's within these values. We can also play around with like how many lines per point and max distance. So you can set things up that are gonna be these really big chains. So this is actually like super effective, and basically this whole field that we've kind of tried working in before of creating this type of plexus effect is really like augmented by this. Let's call that, like make that blue. Like it's really augmented by this technique where we can just sort of add things in really, really fast. Okay. This isn't really meant to be about making things look nice, but I have a problem with that. So I'm just gonna color these yellow in here and make that line sprite bigger. Obviously you could do stuff to kind of layer these things better in your render network. But basically, you know, this is a very cool kind of augmentation that is added to TouchDesigner. Likewise, we have a bunch of stuff like this kind of ability to, let's bring that in, ability to do these types of averaging that we haven't really had access to before. So this is an analyze chop, and we've had analyze in all sorts of things before, right? We have it for tops and for pops and for chops and for everything really. We can analyze certain value points. So like if I made an analyze here, we have a bunch of options for things that we can do. And it's just the same in pops, except we have a lot of very cool things we can do here. So from this analyze, and I'm sending this out to this chop, so I can just move this around in the transform, but you know, you could instance that too. But basically I'm selecting average, centroid, but you've also got minimum, maximum, index of minimum, the sum, the RMS power, all sorts of cool stuff. And I'm basically using this to analyze this point cloud. So if I took this pattern and change that seed, we're going to see that moving around. But also let's see, and I haven't really used pattern much, so let's see if I can figure out how to change this. Yeah, if I turn that down, what we're going to see is our centroid particle is much more kind of centered to the middle. And if I turn it up, and I guess I'm going to press home because you want to home everything in our camera. again, we can see the centroid is kind of stuck in the middle, and that is going to maintain. So this is basically a way that you can find the center of a cluster of points. You also have much more accessible grouping options with the new pops. So if I make some of these things available, let's say I make the RMS power available, I can go in here, and so when I actually access this, I can choose what I'm accessing. So I can have my average and my RMS power, so I can feed out all of these things. Probably won't use RMS power for this, but for average, I could just drag and drop that into my controls here. And it's probably going to be somewhat similar because the average should probably be the center, eh? But we have this way of getting sort of the central point of a lot of data, which is kind of super cool. Other things that we can do that I think are really awesome is we have a much more souped up version of sorting. The TouchDesigner team has really developed and made a really efficient way of sorting here. And what you can do is by combining different textures, you can have these attributes that allow you to basically sort by an external image. So I could take, in this case, I'm taking this pattern chop, which is generating a ramp, or in this case, a sign, but I can then sort by a secondary value, which is this image here. And let's just take a look at what's happening here without that whole section. It looks like I'm probably sorting something that is not available to sort. So I'm going to go into a top just so we can see that output. Okay, so if I go for a sort and I'm sorting by attribute, I can sort by position, which obviously isn't going to do that much. We've got X and Y for this ramp. But if I go in and start sorting by color attributes, we've got our color 0, 1, 2, and we've got our alpha channel, which is just going to give us nothing really, because it's just sorting by an index that's going to be 0. But we can go in and we can do all sorts of cool stuff. And so what is happening in this previous case, going back, is I'm taking the color of this channel here and I'm sorting by that. So I could put anything in here really. I could put in a video of my face. And if I maybe put something really white up to the camera, we'll get something a little bit different. But basically, we can put in all sorts of fun stuff here. If I put in a constant, we might see a bit better how this is working. So the constant is going to remain the same throughout the image, right? So it would have to be maybe something that is a noise, fit that. But then let's have just something that's maybe like 1 by 10. And let's turn the period up to something really high. So more or less, it's going to be the same. Turn it up a little bit. And this can kind of just very easily give you some sort of fun VHS type effects. And I find this really exciting, actually. Oops. That was time. And multiply it by way more. And let's just make sure there's a bit of an offset there. So this is like a super cool effect that I don't think many people will find sort of immediately. But this is something that I'm sort of a big fan of. Also remove that fit and something different is going to happen there. So these are sort of some of the low-hanging fruit that I think are really cool. I also wanted to show you a more sort of just experimental network, or a couple of experimental networks where I am just trying some different things out to see what happens. And essentially this is just experimenting and mashing pops together. And so what I've got going on here is I'm loading in a point cloud, and what's really, really awesome about the new point cloud pop is that we load our file in, we can determine the fields that it has. So in this case, I have position and color. And what I can also do is I can go into this rearrange and I can select a attribute that I want to rearrange. And as we know, when we bring in these point clouds, we have color that's often scaled between 0 and 255 versus 0 to 1, which is what TouchDesigner is expecting. So by default, if I kind of remove this and just have it at 0 to 1, we can see that my point cloud is not colored in any way. So I'd go here, I'd select what I want to work with, which is color, and I would go in and I would select 0 to 255 and set that up to be my color output. And this is way easier than going in and having this in tops, where we have our point file and then our point file select to drag between. And so this is really cool. And then I'm just playing around with a few things here. So I have some kind of multiplier here, which is basically just scaling that to be inside this box. I'm also using a limit a little bit later. I have a twist operator. Unfortunately, my computer keeps stopping recording and I don't notice. So moving back, I was talking to this twist. And so the twist just allows me to create a twist effect to a series of points or geometry. But then what I'm doing is I have this sort of blend math mix, which we can see here is allowing me to decide how much of that twist is being fed forward to allow it to sort of move in different ways around the image. So I'm kind of manipulating. And again, this didn't particularly have I didn't really have an end goal in mind when I made this. I sort of just was putting things together and seeing what would happen. For example, if I changed it to color, first off I get an error, but let's see if I did the second position there, or even just the first position. It moves back to being a sort of just system that's manipulating via that attractor. So let's do the NP, and now this is just going to be that. So this combination is kind of interesting. So then what we have is, obviously I'm just kind of merging stuff together. The blend is not super important, but I'm using it to blend between two different sort of very basic states, and this is more sort of for the feedback loop, but we don't have that much impact from this. Again, this network was more like improvising. And this is where I make my attractor. So I've got my uniforms, so my strength. So if I turn this up real high, we'll see that that attractor is going really intense. Some might say too intense. So let's reset that, and we can see that it's going to pull all this stuff out of the frame. So going back to like 0.1 is pretty okay. Even 0.1 is probably bigger than where I was. And what else have I got going on? And then basically I just have a little bit of proximity stuff at the end, and I'm not instancing, but I'm taking the transform value of this, or I'm taking the value of this sphere, which is being controlled by that noise, which is also affecting where the particle attractor is, and translating that and also scaling the radius of a noise function just to make it not quite so periodic. And so that's kind of this little network here. I have one more network I want to show you before I kind of finish this overview, which is kind of spiraled a little bit. And again, this is like a sort of an improvisation around making stuff in pops. And I think for me, just playing with these tools and just seeing what works, and then having things that fail and maybe things that go wrong but kind of are interesting, is kind of an interesting thing to do. And so this is an example of me playing around with the point generator and sending that into a feedback loop, which is being combined with some noise. I have this math mix here, and this math mix is blending between 2 points. So it looks actually like we just have feedback before and after noise here. So essentially probably not that much going on there. Maybe I could blend in something like this. And let's see what happens there. Not that much different. But essentially it's kind of like this is the start of a feedback loop, and then I'm scaling things with this math here. So this is kind of how in or out I want things to go, and that's actually kind of a nice effect in itself because it allows me to grow in and out this system. That might be something to play with. I have a blend, and this blend allows me to move between either this sort of circular normalized shape or more like the original flat cube. So I can kind of blend between different projections, I guess. And then I have another blend, which is going to allow me to blend between just the starting points of each thing. So we've got our little cube here, or we have, if I play with this blend a little bit more, we have whatever this chaotic circle-y thing is. But essentially by combining these things together, we have loads and loads of control over a bunch of stuff. And for me, like I said, this is just me kind of experimenting with stuff. We have this trail here, which again is really great because it's going to be instanced, or not instanced, it's just going to go into that geo. We can just turn up this scale. It does kind of mess with the frame rate a little bit, but super, super cool. And what we could do is we could very easily have this trail, and then we could also just create a geo for this null. Maybe make it into a point sprite. Okay, my computer stopped yet again. Basically, I've attached this point sprite. I'm going to make it pink so it's really obvious. And I'm massively going to turn up that point sprite size. So if I go in and zoom in, basically the first particle of our trail is attached to a point and then the rest of the trail is not. Obviously you could go in and do some more kind of extravagant stuff, but it's really easy to mix and match multiple data points together here. And overall I am really enjoying working with pops, and obviously if I kind of flip that value, well, that's kind of crazy, but if I move these values around, I'm able to get some very different outputs. And that is a lot of fun. So I'm going to be publishing a sort of a free starter pack of some pop stuff on my Patreon, so please sign up for that. Like and subscribe to my YouTube channel because there's going to be more in the future on pops. And I'm sorry the video kept kind of crashing and if this was a bit disjointed, but I am sort of super excited by these. I'm going to be learning a lot more about them over the coming weeks. I'm glad I've been able to spend a couple of weeks playing around with these already, and I'm excited to see what everyone else in the community does too. Thanks for watching.